Hello students, in previous videos I have explained you how to solve the definite integrals by using one property. In this video I will be teaching you another property using another property. See here the property is written integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. The difference between the previous property and this one is here the lower limit is 0. As you remember in the previous videos I told you that if the lower limit is 0 is there, another property you have to use, and that is this property. In this property always when you have to use this property, when the lower limit is 0 and the upper limit is any number or constant, then you can apply this property. How you have to apply is in the function f of x, wherever you find x term, in place of x, you have to substitute a minus x. This a is the upper limit of the integral. So put a minus x in place of x. Now let us solve this one and see how this property can be applied in solving this definite integral. So, what is the question given here? Let I is equal to integral 0 to a root x upon root x plus square root of a minus x dx. First of all, let us consider this equation number 1. Now applying this property. Okay, before applying this property, let me tell you how to identify this question so that you can come to know how you can apply this property here, or when you have to apply this property here. Here, see the question, the lower limit is 0. As I told you, if you want to apply this property, in the integral the lower limit must be 0. And the main thing is whatever term is there in the numerator, that term must also be there in the denominator. Here see in this integral, in the numerator, the term is root x. Same thing is also present in the denominator, that is square root of x. So this is the identification for the property which you have to apply for the numerical, for the integral, where you can apply this property. First one is how you can identify. Let me repeat. The lower limit must be 0 and the term which is there in the numerator must also be there in the denominator. In this case, root x is there in the numerator and also in the denominator. Now let us see how to apply this property. So, applying property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So I is equal to integral 0 to a, in place of x, as I told you earlier, put in place of x, put a minus x. So here a is same a, so what you will get in place of x, a minus x. Also in the denominator, in place of x, a minus x plus square root of a minus, in place of x, a minus x. One thing you keep in mind, always put a minus x within brackets. Don't forget putting brackets. Always put a minus x in brackets. Okay, now we will simplify this. Integral 0 to a square root of a minus x upon square root of a minus x plus square root of a. Now here see, there is minus sign is there. When you open these brackets, the sign of both the terms will change. This will become minus a, and minus into minus, this will become plus a. So minus a minus into minus plus x dx. So plus a minus a will get cancelled and you will get integral 0 to a root a minus x upon root a minus x plus here x is left, so root x. Let us consider this as equation number 2. After you get equation 2, add these two equations. So adding equation 1 and 2. In the left hand side, in both the equations, I is there. So I plus I. And in the first equation, in the right hand side, integral 0 to a root x upon root x plus root a minus x dx, plus in the RHS of the second equation, integral 0 to a root a minus x upon root a minus x plus root x dx. Okay, so I plus I is 2i. Let me rub here. In the left hand side, both I plus I is 2i. So 2i is equal to, here in both the integrals, integral limits is same, 0 to a, 0 to a. So you can take common integral 0 to a, and denominator of both the fractions are same. So when you take the LCM, if the denominator is same, you will get the same denominator, that is root x plus root a minus x, and in the numerator you have to add both the terms, root x plus root a minus x dx. And as I told you earlier in my previous videos, whenever you add equation 1 and 2, when you are applying the properties of the definite integral, after adding 1 and 2, you will definitely get both the numerator and denominator same. And if you are getting it same, then you are going correct, doing the sum in the correct way. So cancelling both numerator and denominator, you are getting 1 dx. So 2y is equal to integral 0 to a 1 dx. That is 2y is equal to integration of 1 is x. Keep it within brackets, limit 0 to a. Now we have to apply this upper limit and lower limit in place of x. Substitute that. So first upper limit in place of x, then minus sign will be there, and then lower limit. So a minus 0 is a, 2y equal to a, therefore I is equal to a upon 2. So this is the final value of the integral.